Alright, today we're looking at creating equations, and then also we're going to look at parallel and perpendicular lines. Our vocab today, our first word is parallel lines. It's lines that will never intersect each other, meaning they will never touch, and they have the same slope. So we can look off a graph and identify parallel lines, but we can also look at their equations and know that they're parallel, since they'll have the same slope, but different y-intercepts. Perpendicular lines are lines that intersect each other at 90 degrees, and their slopes are negative reciprocals of each other. So once again, we'll be able to tell based off a graph if lines are parallel if they create a 90-degree angle at their point of intersection, so where they cross, and then also by looking at the slopes of their equations, and they'll be opposite or negative reciprocals of each other. Alright, so let's practice determining the negative reciprocal of each number. So keep in mind the negative part means the sign will change. So the negative reciprocal of positive 6 will be negative, and we think of 6 as 6 over 1. So the reciprocal of 6 over 1 is 1 over 6. So the negative reciprocal of 6 is negative 1/6. Now the negative reciprocal, negative 2, since it's negative, it will be positive. And once again, just as we did with the 6, think of it as 2 over 1. So the reciprocal of 2 over 1, keep in mind with the reciprocals, you flip your numerators and denominators. So your denominator becomes your numerator becomes your denominator. So our denominator of 2, or excuse me, our denominator of 1 becomes our numerator, and our numerator of 2 becomes our denominator. Alright, the negative reciprocal of negative 3/2, once again, will be positive, and we switch our numerator and denominator, so our negative reciprocal will be positive 2/3. Our negative reciprocal of 7 will be negative 1 over 7. Our negative reciprocal of negative 1 over 2 will be negative 2 over 1, which we can look at as negative 2. And then our negative reciprocal of negative 6/7 will be positive 7 over 6. All right, now we're going to look, are the equations perpendicular, parallel, and why? And we're going to graph both equations. So first we're going to take a look at identifying if our equations are perpendicular or parallel based on the equations. So we want to write everything in slope-intercept form. So in the form y equals mx plus b. Now our first equation is already in that form. Our second equation, to write in slope-intercept form, will add 6x to both sides. So we will get 2y equals 6x plus 6. And then we will divide both sides by 2, not 3. All right, so we get y equals 3x plus 3. So now both equations are in slope-intercept form. Now these lines are going to be parallel since the slopes are the same. So these are parallel because the slopes are the same. They have a slope of 3. And the y-intercepts are different. Now if the y-intercepts were the same, we'd have the same exact line. So they would be intersecting at every single point. But since our y-intercepts are different and the slopes are the same, our lines are parallel. And to graph the first one, we have a y-intercept at 1. We go up 3, 1, 2, 3, and over 1. Connect our dots. And our second equation, we have a y-intercept at 3. Go up 1, 2, 3 over 1. And as you can see, the purple and the green line will never intersect. So these are parallel lines. All right, the third problem we're looking at is y equals 1/2 x minus 2. And then we have 2y plus 4x equals 12. Once again, we're going to rewrite that second equation in slope-intercept form. So we're first going to subtract 4x from both sides. So we get 2y equals negative 4x plus 2. Then divide both sides by 2. So we will get y equals negative, this will simplify down to 2x plus 1. Now once again, we have both of our equations in slope-intercept form, and we're going to be comparing our slopes. So our first equation has a slope of 1/2, and our second equation has a slope of negative 2. Now if we take a look, one's positive, one's negative, and negative 2 is the negative reciprocal of 1/2. So these equations are perpendicular because their slopes are negative reciprocals. So we are perpendicular because these slopes are negative reciprocals. And keep in mind we're asked the y part, so that's what we need to explain. So to graph our first equation, with y-intercept of -2, a slope of 1 over 2, connect our dots. And then to graph the second equation, we have a y-intercept at +1 and a slope of -2, so down 2 over 1 to the right, or up 2 to the left 1 to the right. And this point of intersection creates a 90-degree angle. So that's how graphically we can tell the two lines are perpendicular. All right, the next one, we're going to write an equation that represents the problem, then we're going to graph it. So Jenny receives $500 for each car she sells. Let X be the number of cars and Y be the total money amount. So we're going to write this in terms of Y equals MX plus B. So we're still using that setting. So the amount of money that she earns equals each car that she sells will be X times 500. So our equation is going to be Y equals 500 times X. And then to graph that, on our x-axis, once again, we have the number of cars sold. And our y-axis is the dollar amount. So if she sells one car, she makes 500. If she sells two cars, she makes 1,000, and so on and so on. And you want to make sure your axes are labeled. And from this equation, since we're looking at real world, all right, we're going to take a look at 5. We're earned $7.50 per hour. So let X be the number of hours you work and Y be the total dollar amount. So we're going to have Y equals 750X. And this equation came up. We'll have a number of hours. It's our x-axis. And our Y value axis is going to be the total dollar amount. And for this one, my x-axis is I'm going to count by hours. And then my y-axis, I'm going to go by 5. So I'm going to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and so on. So if I work 1 hour, you'll earn $750. If you work 2 hours, you'll earn $15, 3 hours, so on. And that will be our equation. Hope you have a great weekend, and I will see you Monday.